Hello everyone. So nowadays we are living in the AI hype. Everyone is talking about the latest large language model, the state-of-art image recognition model, etc. But the secret behind all of these models are good data. You need good data to train them well. And to have good data, you need good data engineers, which is my profession. I'm a data engineer, and I would like to teach you different libraries that I personally use in my day-to-day job. The first library that I have chosen is Pandas. It's the go-to library whenever you want to perform data wrangling, data analysis, and any preliminary study on the data. And in this series, I'm going to teach you Pandas from the basic to the very advanced topics. So come along with me. So in this series, I'm going to use Conda Environment and Jupyter Notebook. If you don't know what are they, don't worry. You don't need them to follow these videos. However, I'm going to use Conda Environment for separation of different Python libraries and Jupyter Notebook to write and execute code and see the results immediately. If you have a question about these tools or you want a tutorial for them, leave me a comment for that. So right now that I am inside my virtual environment, I would like to install Pandas. The command is simple, pip install pandas. And now Pandas is installed. The other tool that I'm going to use is Jupyter Notebook. After opening Jupyter Notebook, I'm going to create a notebook. Let's see if we have Pandas installed. So import Pandas as PD. If you see here, it is finished without an error. So I have Pandas. Let me show you another library that is not here and you should see the error. So for example, if I would like to import PyTorch, it will give me this error, no module name PyTorch. So if you are receiving such an error, you have to install the library with pip. The other library that you always use along with Pandas is NumPy. If you like to have also a tutorial for NumPy, write me in the comments. But in this series, I assume that you know what is NumPy. So in this second part, I want to talk about the data structures that are available in Pandas. The whole power of Pandas actually is because of the powerful data structures that Pandas use. So let's deep dive into it. In Pandas, you can represent this list as a data structure that is called series. Series are the base for all of the Pandas data structure. To make it more clear, a Pandas series is a list that you have assigned an index to each member inside the list. So inside Python, the index for each member is 0, 1, 2, 3. So it's the position of those members inside the array or the list. However, in Pandas series, you can put whatever index you like. For example, here I've put A, B, C, D as index, and later I can access these information, so the numbers within the list using these indices, or I can put simply numbers. Let's take a look at both examples. In the first example, when I create this series using A, B, C, D as indices, you see that the series that is created is assigning the characters that I have used to each number. So later, if I want to, for example, get access to number 1, I can use this index like this. So I have used the lock method, lock for location, and I said, give me whatever is inside the location A, and it gave me 1. You can imagine that instead of A, B, C, D, you can put whatever else you like. For example, you can put the name of students, and then what is here can be the grade that each student got inside your exam. For example, consider that right now my series is the grade that each student has got. So the list inside Python is the grade that each student has got, and this index is the name of students. Now I can easily understand what is the grade that, for example, Sam got within the exam. I just use this function, lock, and then the name of the student. And here it is, Sam got 80. You probably have noticed this mp.integer64. Whenever you enter numbers inside Pandas series, it gives them a data type. The best data type that it could give to these numbers is an 64-bit integer. If you like to give different data type to these numbers, you can do that as well. For example, if you don't want to use 64-bit of memory for every integer, you simply can pass here dtype is equal to and the string int 32. Doing so will give you the 32-bit integer. So if, for example, you know that you have small integers, instead of using 32 bits of your memory, you can use even integer 16 bits. The other thing to notice is that right now I am using the lock method to get the location, to see inside the location that Sam is its index, what do I have. You can also access the grade of Sam simply as you do within your Python list. So if I use, for example, my series Sam, it gives me the same result. Series gives you another possibility to access the data that it has. You can use iLock method. If you want to get the first number that is within this series, you can use iLock 0, and if you run this, it gives you the first grade. Here, the index is Sam, but this 0 is the position. The second data structure that I would like to use is data frame. A data frame is a two-dimensional table. Let's make one data frame. To create a data frame, you can simply create a dictionary with different information. For example, name of people, age of people, and the score that they got. Then df is equal to pd.dataframe data. So you use the constructor of data frame and you pass this dictionary to the data frame. And now you have a data frame from this information. Here it is. You have the column name, age, and a score. And these are the indices. You remember about indices when we've talked about them in series. This is exactly the same. If you don't like 0, 1, 2, and 3, you can pass other indices. You just need to use index here. For example, I've passed index as ABCD, and here you see that in my data frame, I have indices ABCD. So you see data frame is like more or less a Python dictionary. It's a 2D data frame. If you're familiar with databases, probably you have noticed that Pandas data frame is really similar to the tables that you have in SQL-based databases. So right now that we have created a Pandas data frame, let's take a look at some of the methods that this powerful data structure gives us in order to perform data inspection. One of the first method is the head method. So df.head, it will give you the first 5 by default, the first 5 rows of your data frame. Right now we only have 4 rows, but it gave me the first 4 rows. If you don't want to have the first 5 rows, which is the default number, you can put whatever number you like. For example, here I put 2, and it will give me the first 2 rows of my data frame. This is a really useful method because it tells you more or less what kind of data types you can expect from a data frame. For example, you see the columns, you see the index, what is the index. So it gives you really useful information. If you don't like to see the head of your data frame, if you want to see what is at the end of your data frame, you can use the tail method. Again, tail, like head, will show you the last 5 elements of your data frame. Because we have only 4 elements, it is showing us everything. But if I limit it to only 2 rows, you see that it shows me the last 2 rows of my data frame. So Charlie and Diana. The other important method that you can use within the data frames is the info method. If you perform df.info, it gives you all of the useful information that you might need about your Pandas data frame. At first, it tells you what is the class that you have asked for the info. Then it tells you how many entries you have with the indices, and then it talks about the columns, if they are null or not null. If, for example, you have a null value within these columns, it will show you, but right now all of the 4 rows that we have within these columns are non-null. And also it talks about the type. If you don't like these data types, you can of course change them. But before showing you how you can change the data types of the columns, I want to talk about another important method inside Pandas data frame, and that is the describe method. The describe method in Pandas data frame gives you really important information. It tells you how many values each column has, what is the mean for those values, what is the standard deviation, the minimum, maximum, and also the percentiles. So this is the 50 percentile number, so this is what we call median. And in this example, median and mean are the same for age, but if you take a look, the median and mean are not the same for the score. By the way, if you don't know what are these percentiles, write me in the comments so I will create a video about the basic concepts in statistics. Great, right now that we are able to inspect our data frame using the head, tail, info, and describe method, it's time to select some of this data. The first way of selecting data within Pandas data frame is selecting a column. So what if I want to select the age of all of the students that I have? So it's simple. You can think of the name of the columns as their somehow index. So you can use the bracket to get the data, and this is it. So this is the age of different students that I have. Take a look at this form. Isn't it familiar for you? While I was teaching you Pandas series, you probably have seen this form. Look how similar it is to this form when I have used the column selector in this data frame. It seems it has given me a Pandas series. Let's take a look at the type. So I use the built-in method Python type. Here it is. So it's series. So a data frame is a combination of different Pandas series. Each column is a Pandas series. Also, each row is a Pandas series. But how you get a row? Let's take a look at that. If you want to take the first row within the data frame, you use the iLock method. So this is the first row. Alice, she is 25. Her score is 85.5. And this is also a Pandas series. Let's use the Python built-in type method, and here it is. This is a Pandas series. So all rows and columns within a Pandas data frame are Pandas series. Right now that I have talked about iLock method in Pandas data frame, this is a powerful method. It not only let you to catch the rows of pandas, it also lets you to catch a specific value. For example, if you want to catch the value within the second row and the first column, so Bob, here is how you catch that data. So df.iLock, second row, so index 1, first column, so index 0, and here it is, Bob. This is a powerful method that not only led you to get rows, but also let you to get a specific value. In case you wanted to use iLock method to get a column instead of a row, you can do that. Probably you're familiar with this syntax within Python list. So iLock give me everything within the rows, so select all of the rows, but select the first column, and this is the result. It gave me the column name. You remember when I have asked for the column age, the name of that column was age. Right now that I've asked for the first column, the name of that column is simply name. Like Pandas series, also Pandas Dataframe has the other method, lock. So you remember that in Pandas series, we've talked about lock method and then iLock method. Here also we have the lock method as well. So while iLock uses numeric indices, exactly like a Pythonic list, lock method use the indices that you have defined when you have created your data frame. So in our data frame, we have A, B, C, D as indices. So this is why when I want to get the first row, with iLock, I simply passed number 0, but with lock, I have to pass the character A. And this is it. This is the first row. Now, if I want to get a specific value within the first row that is identified with the index A, I can do this. So I have passed the index A and the column age. I said the first row that has the index A, give me the value under the column age, and this is the value, 25. Let's check that. The first row with index A, I wanted the value under column age, and here it is, 25. Lock and iLock give you other possibilities as well. So whatever you are able to do with Python lists, you probably can do them with iLock and lock method as well. Keep it in mind. You just need to know the correct syntax. Let me show you some examples. For example, consider I want to have everything between the second and the fourth row, and I want the columns, first column till the second column. If I run this, it gives me a small data frame. So here it is. It gave me the two values for the first column. If I want to have both columns, I will change this one to 2, and here it is. So I have the values for columns name and age for the second and third row. If instead of using these Pythonic indices, so the numbers, if you want to use the indices that you have defined, so A, B, C, D, name, age, score, you can do that with the lock method. Let's take a look at that. So the equivalent of df.iLock 1 to 3, 0 to 2 is df.lock B to C, which are the indices, A, B, C, D. Do you remember? We have defined A, B, C, D as indices. And column name to column age. Pay attention. When you use the lock method, the last index that you mention is inclusive. It's not like iLock or Pythonic lists. In the Pythonic list, whenever you're using the column syntax, what comes after column is not included. However, when you use the lock method, what comes after column is included. Right now, what if you want to find all of the students that are younger than 35 years old. You can do that using a concept in Pandas Dataframe known as Boolean masks. A Boolean mask is a mask that will give you true or false based on the data that you have. For example, in this example, we would like to know if within our data frame the column of age is less than 35. Just to make it clearer, let me also print the data frame here. So you see, for the first row, Alice has 25, so Alice is less than 35, so the mask is returning a true. Bob is less than 35, the mask is returning true here as well. However, Charlie and Diana are older than 35, so the mask is returning false for them. Let me call it mask. Now I can use this mask to filter the data frame. The syntax is like this: df brackets mask. And here is the data. You know that only Alice and Bob are younger than 35 years old in our students. So when I have used this Boolean mask that I have created, this data frame has returned only these two students. You can write it in a shorter way. I want all of the information that the column age is less than 35 for them. It does the same task for you. Now you also know how to use the Boolean masks to filter your data. Again, if you're familiar with databases, you probably have noticed that this is how the where condition in SQL works. Just select everything where column age is less than 35. This is the exact syntax of where clause in Pandas. Great! Right now you're able to select different data inside the data frame using their location, their indices and column, or Boolean mask. Now what if you want to save this data frame? In data engineering, you save data frames in different formats, but the most famous ones are CSV, Parquet, and JSON. Now I'm going to show you all of these different formats, how you save data to them, and how you read data from them. So whenever you want to save your data frame as CSV, you simply use the method toCSV of your data frame, and here you pass the path to the file that you want to save. Here I'm passing just the name, so this data.csv will be saved at the location of this Jupyter notebook. Let's take a look at it. Okay, it was successful, the data is saved. Let me come here. This is the data.csv. Let me open it, and here it is. So this is the column name, age, score, and you see different rows. Now if you want to read this information from a CSV file, you will use a simple read CSV method. So right now that I have saved my information within this data.csv, I use pandas read CSV. So pay attention, before I was using the dataframe.toCSV method, but here I use the pandas.read CSV method to read the data. And this is df from CSV, is something that I have created now. It didn't exist before. And when I run it, you see that I have read this CSV. The difference that you see is that when I have saved the CSV, I also have saved the indices, so A, B, C, D. But right now that I'm reading this CSV, you see that it adds a column for me and put all of the indices here. If you don't like this, you can simply avoid the index. How you can do that? Well, when you are writing to CSV, a good practice is usually performing index is equal to false. So you do not save the indices of CSV. By the way, when you have a column name and you have different columns, you don't need to use a different index for them. Those indices can be default Pythonic indices 0, 1, 2, 3. A good practice is to perform index false. Now, if I read that CSV file again, those indices are not saved within the CSV file. And now, when I read the CSV file again, you see that I don't have that extra column. The other format that you can save your data frame with is the Excel format. So df.toExcel, data.xlsx. If you're familiar with the Excel, you know that Excel and CSVs are not really different. So it's normal that you can also save your data frames to Excel format. Pay attention to this index false, so I don't want to save indices. And I got this error. No module named open PyXL. If you want to save your data frames to Excel format, you need this module. It is not included within your pandas. So don't get panicked. Here you can install that. Pip install. Okay, it's installed. Now let me perform this, and here it is. I've saved the file to Excel format. This is it. I don't believe that Jupyter Notebook can read Excel format exactly. However, you can read that file using Excel, and as you see, I have created an Excel sheet using our data frame. Let me do a bit of zoom in. So we have saved our data frame in Excel sheet. The library that I've showed you, so one more time, it's OpenPyXL. Thanks to that library, you can also read the Excel format files. So here it is. I read the Excel file that I have saved, and you see that I have my data frame. The other method to save the data from a data frame is toJSON method. So this is the method df.toJSON, data.json, and take a look at it. Orient records. So it tells the toJSON method that you should save the data frame as a list of dictionaries. Don't overthink that. If you're really interested about understanding this, read the documentation, take a look at that. Now data.json is saved. Let's open this data.json with Jupyter Notebook. Here you see I have a root for my JSON, and for the first row I have a dictionary. So this is a list of dictionaries. So the first dictionary that I have is name Alice, age 25, score 85.5, and these are different rows that I have, and each of them is a dictionary with its key and value. So if you didn't get how it looks, let's take a look at it using the JSON library. So import JSON. I just opened the file using the Open API of Python, and then I am using the JSON library to load the file and to show you the file. As you see, the file is saved as a list of dictionaries. This is what I told you that this orient method is doing. It is saving the data frame as a list of dictionaries. The other data format that we use whenever we want to save a data frame is Parquet. This format is usually used whenever you have huge amount of data and you would like to save it in a binary format so it takes less amount of space within your disk. So to save your data as Parquet, you need to use the toParquet method, data.parquet. So here you got the error. In order to save your data as Parquet, you need a Parquet engine. One of them is PyArrow that is so fast to read and write Parquets. So let's install PyArrow. Okay, right now that PyArrow is installed, here it is, the data is saved as Parquet. Let's take a look at the file system, and here you see the data.parquet. I am not able to open it. If I open it, probably it will tell me this error. It is not UTF-8 encoded, so because it's a binary file. To read Parquet, you can use Pandas library, read Parquet method, and you pass the name of the file, actually the path to the file. Here it is, and take a look at the difference between CSV and Parquet. Do you notice that when I've saved my data in the Parquet format, I didn't mention to remove the index, and I've managed to save my data frame and load it exactly as it was. What do I mean? Let's take a look at it again. Let me copy the CSV here and let me remove this index is equal to false. Let me also copy and paste the read CSV method. Okay, now let me save my data frame to CSV one more time without the index false. Let me read that. You see my data frame somehow is changed, is modified. The indices has been saved as another column inside the CSV. However, when I have saved the data to Parquet format, I didn't ask index to be false, but when I read it from the Parquet, I get exactly the data format that I have saved before. This is the other beauty of Parquet format. So besides the fact that it's a binary format, it saves a lot of space for you, it also gives you the possibility to save the exact data frame that you have within your, for example, Jupyter Notebook on your disk. And then when you read that, you have the very exact data frame. So we got to the end of our video. I hope that you've enjoyed the video and you have learned something with me. Please write me in the comment if you have any question, if there is anything I can improve within this series, and if you like to stay with me in this series, please like this video, subscribe to this channel, and click the ring button so whenever I post a new video, you will be informed. Thank you so much for staying with me till now. I wish you a great time. See you soon.